Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
First thing I want you to recognize is what is a transformation happening. So just like in the reciprocal function, since it's inside my quadratic here, then that's going to be left or right, or my C value. It's transforming horizontally. So in this particular case, it's moving to the right 1 unit. So remember, what does our parent function look like? Our parent function looks like this. So if I move it to the right 1 unit, what I'm essentially moving is that vertical asymptote to +1. Everything else stays exactly the same, just like that. So my domain is going to be all real numbers except 1. Now you can check. If I plug 1 into here, I get out 0 in the denominator. So all we have to do is exclude 1. Now my range is going to be exactly the same as the parent function. It's never going to touch the x-axis. My vertical asymptote comes from my denominator. So I can see that if I let x equal 1, it's going to give me undefined value, so that's my vertical asymptote. My end behavior asymptote, so I'm abbreviating these now, is going to be the ends. And I can see nothing has changed for my parent function, so it's still the line y equals 0. So just to remember, vertical lines are x equals, horizontal lines are y equals. Now my x-intercept, there isn't any. I just moved it to the right. So if I move it left or right, I create no x-intercepts. However, if I move it left or right, I do create a y-intercept. So we can actually solve for that. So we're going to plug 0 into our f of x function and solve. So we get that as our y-intercept, which kind of makes sense because we should get a positive value. Let's look at another example. First thing, what's happening? Do you recognize we have a +2 on the outside? So that is moving up or down, so this is going to move up 2 units. Now, remember what our parent function looks like. So if I move this up 2 units, notice it's still going to be along or asymptotic to the y-axis, but now that bottom part of it is going to change. So if I move it up 2, then essentially the imaginary horizontal line, in this case that it is avoiding, is going to move. So let's talk domain. Domain is still all real numbers except 0. Range, okay. So my graph looks like this. So the range is going to be anything approaching 2. So we're going to say from 2 to +infinity. Vertical asymptote is still exactly the same as my parent function, so x equals 0. End behavior now has been changed. It's no longer the x-axis. It's been raised up to 2. So we're going to write y equals 2. X-intercept? Nope, not happening. Y-intercept? Nope, not happening because all I did was move it up. There is no y-intercept here. Let's look at one more example. Now, I gave you a bunch of transformations this time. Let's see if you can figure them out. First, let's remember what the parent function looks like. Now, how many do you count here? Look at the graph here. How many transformations do you see? Do you see 3 of them? 1, 2, 3. Let's list them. I'm going to go left 3 units. I'm going to go down 1 unit. And I'm going to reflect over the x-axis. Okay, so let's think about this. This is what our parent function looks like, right? If I move to the left 3, I am now moving the vertical asymptote. So my vertical asymptote is now at -3. If I move my graph down 1 unit, then that end behavior asymptote now goes to -1. And I reflect it over the x-axis. So wait a minute, if it normally is above the x-axis like this, then I reflect, it's going to be down, down like that. Now let's analyze it. What's my domain going to be? Well, look at the denominator. What's the only number I can't put in there? -3. Again, how do I know that? Because if I put -3 in, it gives me 0. Let's talk range. Our parent function says the range is from 0 to positive infinity. However, I've reflected this, so now it has a value that it's avoiding from the top, which is -1, but it's going to negative infinity. So I'm going to say from negative infinity up to -1. Vertical asymptote. Well, the vertical asymptote's -3, so say x equals -3. And behavior asymptote is this horizontal line here. So our function is getting close to that line there, so we're going to say y equals -1. X-intercepts. Nope, not happening. There is none. Y-intercept. Okay, we can see there is a y-intercept, so let's solve for it.